61 and 62 by the end of class. But I am going to make some time for questions at the end. And once again, if you guys don't have questions in the beginning ones, at the end of class, once we finish the lesson, what could you be doing? How could you be using your time waiting for your question? Yeah, start on homework for tonight. So let me show you homework for tonight. Let's go ahead and take pictures, write it down now. Yeah, it's not bad. No, not necessarily.
So we can take a picture now?
Yeah, go ahead and take a picture now, write it down now. That way when we get to homework questions from last night, 61, 62, if you don't have a question on a problem, you can quietly be using your time wisely and starting on homework. But some of you will have questions later, so no one's going to turn in homework until we go over as many homework questions as we can. And that way, if you don't have a question on some of the beginning ones, you can just start on your homework and then just listen up for that number where your questions start, and you can start paying attention to homework questions. Does that sound good?
Yeah.
Okay. That way we use our time wisely and try not to waste it. All right. Page 572, 3 through 14. We're going to come back to that in just a second, but I do want you guys to start your notes. Remember, we're coming back to homework questions in just a second. 10.4. Inverse. Guys, let's clean up what we're saying and our attitudes as well. We got this. We got this. Just quick reminder. Smartboard's not working. Quick reminder. Our test is Tuesday. That's what I said the other day.
For finals.
It hasn't changed. It's the same as the other day. Which means.
Hold on there.
We're starting 10-4 today. Today's Wednesday. Finishing 10-4 tomorrow. Thursday. And we're reviewing both Friday and Monday. So we get 2 full days of review. That's why Tuesday, I guess I could have had it Monday, but that just sounds like it's going to be a bad test, right?
Yeah.
So we're going to review Friday, review Monday, test Tuesday, then we can start reviewing for finals, and we'll have like a full week and a half, maybe almost.
What are we getting homework?
Well, I need to make sure you guys are actually reviewing, so there will be some, but it won't be like a huge load. It'll be spread over multiple days.
Oh,
Jordan.
For tests that we took most recently,
No, because I want you guys to focus on this test on Tuesday. You guys will probably get it on Tuesday.
this coming Tuesday, I only put in a memo before that, maybe.
To be honest, things have been going wrong with technology in here, so I'm really focused on just trying to finish the year and get notes on the board every day. So I will grade it as soon as possible. I won't be caught up on all my grading until this week. Okay, when we get to the input versus output, on the notes, when you guys have gotten down to being able to write input versus output, where have you guys heard these words before? Input and output. Angel, input or output? Maybe foiling? Jordan's thinking tables, input, output.
Oh, yeah.
Tables of input and output. I think that was from last semester, right? Okay. Where else? Nobody's thinking about technology? I know some of you guys have games, really? Input?
Like
Don't you have like video, audio? Yeah, right? Like there's input
Oh!
and output.
Okay.
So you guys just get stuck in algebra after a while. Okay, so input, output, right? Input, if I have cables, like for instance this morning, my computer's just being super dumb. It's not playing stuff. It's not hooking up to the smart board. Like it hates everything right now. That one over there. It's not mine. It's the school's. I'm trying to make it work. But I had to go trying to use that DVD player that I haven't used in ages because I haven't had to. I've been able to play it on the computer. And in the back, some of the cables. It's okay, Dylan. Just be careful. Back there, I had to figure out because some of the cables were detached because I hadn't used it recently, and I had to figure out like an audio video input output. Okay. Question. What needs to be plugged in to the input ports on like a DVD player? Not the specific cables, but what goes in those? What's happening in the input? Yeah, right? There's something being fed in, right? If it's an input, something being fed in, and if it's called an output, what's going on? Something's coming out. So, question, what's like think of your family, and maybe your family doesn't have this, maybe your friends do, but like a home stereo system, some sort of like your entertainment center where all of that happens. What's something that would need to have something plugged into its input cables? No. What's a device that would need something coming into it?
Speaker.
Okay, a TV. A TV, you have inputs in the TV because it needs to get fed to the screen, right?
Refrigerator.
That's just a power cord. I mean, there's maybe water coming into the ice maker, but I was thinking of the input cables. What else? Speakers. Yeah, if you have like surround sound, or if you have like one of those like speaker bars, you need the right, and you need to have sound coming into the speakers, right? Okay, what's a device that would have an output? Yeah, input. Well, there's not a lot that gets fed into your phone though. Usually it's your phone being plugged into a speaker, right? It's like the phone aux cord from the phone to the stereo, like in your parents' cars, if they plug in their phone through the aux cord. That's an input because there's sound from the phone going to the stereo in the car. But what has output?
Guitar.
Huh?
The calculator. Portable charger. The
Amplifier.
What is this?
Wait, I don't think. Okay, a portable charger maybe, because are you guys thinking the power comes out too? Is that what you're thinking? Okay, what else? An electric guitar, sure, the sound's coming from and it's going out from the guitar. What else?
No. Not at all.
Well, no. Well, I could make an argument for that, but I don't think any of you guys would realize this. There was a time when you could, before all of this. And not before projectors, we just didn't use them as much. But a calculator I could plug into this little device, I could put an overhead projector, and the calculator would send out information and it would get put up on the screen through this thing. But that's not usual. Usually you plug it into your computer and the computer sends things to your calculator. It's more of an input than an output. I was thinking something like a Blu-ray player, right?
Blu-ray.
Because you're playing your disc. I remember that.
Yeah, it's like, Blu-ray and then normal.
Oh,
And
okay.
then get like a record
And then you're like, oh, no. But wait, guys, why is a Blu-ray player, why does it have output?
Because it takes the DVD and then it
Yeah, it's playing the DVD, and where is it sending it to?
Output.
Usually to the TV, and then maybe to a speaker system as well. Anyway, all that to say, maybe a lot of you guys haven't had to set up entertainment centers, but long story short, there are inputs and outputs. Inputs, you have stuff coming in. Outputs, you have stuff going out. Now, I need to show you how input and output relates to equations, and it should be reviewed. Some of you guys were like, wait, I kind of remember this from last year. If I was to give you, I'm going to make up an equation, so it's not like it's a magical equation. Let's just say y equals 3x squared plus 1. All right. A lot of people in the math community actually say before you learn the letters x and y, you should learn the words input and output. Because equations are all about inputs going in and outputs coming out, meaning something comes in, information comes in, gets processed, and then comes out. And that's hugely applicable to all sorts of things, especially in technology these days. Something goes in, gets processed, comes out, right? So then, if we look at this equation, my question is, does anyone know which variable goes together with the word input? X goes together with the word input.
X goes with input.
Now, a lot of classes start by teaching independent and dependent variables, which isn't bad, independent and dependent variables. They're not bad. But it's a little better to think of input and output as far as the actual application of equations. So X is indicative of whatever information is coming in. Dave, totally focused? I'm not so sure about it. Come on, buddy. X symbolizes what's coming in to an equation. So then what variable is going to symbolize what is coming out of an equation? What? So X symbolizes what's coming into an equation. Y symbolizes what's coming out of an equation. Okay? So in that, or with that regard, when we or you see the notation f of x, this is why this notation is so important. Bless you. Because f of x says, okay, there's this guy called y. He's the output, and this notation shows, hey, what's going inside of him, and the answer is x. F of x, it shows the input. Now, with that, let me go ahead and then say, what if I wanted you to find the following? Find or solve for the following, okay? We're reviewing function notation just for a couple seconds. It's not going to be long. What if I was to ask you, given the equation up above, what if I wanted you to find, first of all, f of 2, f of b, and do one more, and f of x minus 1. I didn't get to teach this to you last year, or last semester, so I'm just trying to make sure we understand the idea of input and output. The reason is, the word from today, inverse, flips what's going on in each of these cases. And so in order to understand how to flip it or how to reverse it, we have to understand how to do it in the first place. Does anyone remember, what do you do when I want, or I ask you to solve for f of 2?
Then if you get the equation, oh, is it the reduced,
Yeah.
or so doing 3x squared?
Isn't 2 the input?
Yeah.
So
Who was the input before?
3
X was the input. What's changed? The input is 2. So where am I putting 2 in the place of x? So let's go ahead and see if we can write that. Some of you would say, hopefully, look at the equation up above. This is our model, this is our guide. So instead of putting in x, now we're putting in 2. Focus, focus. So I had 3. Now, does it look nice if I just write it like that?
No.
You gotta put the parentheses.
Yeah, let's put those parentheses. Now, when you have x's, they don't usually show parentheses. I put those in myself up above, but with numbers, we need parentheses to make sure that we don't think it's 32, like it's 3 times 2 squared plus 1. Now, PEMDAS, yeah, PEMDAS says exponents first, so we would do 2 squared, which is 4. Then PEMDAS says multiplication next, so then 12 plus 1. So what's my final answer for f of 2? 13. That's the output. So the input was 2 to my function, and the output was, what was the result after plugging in?
Where are you?
White.
Because if I want f of 2, I need to know what to put it into, and it says, hey, put it into me. Oh, that's who I'm putting it into. F gives us the name of who to put it into, or what to put it into. If this was g of 2, well, hopefully they would give us a g of x, and that's who we're putting it into. Okay? So then for letter B, when I say, or when I wrote instead, f of b, question, where is that b? Well, first of all, is that b an input or an output? It's an input. We're putting in b. Where are we putting him into? The x of the function up here. We're still using him for all these problems. The equation can change, but what I do does not. So I'm going to go ahead and put 3 down here. And what am I putting in the input spot?
B.
Yeah. X is just the input spot. So I need to put in the B. Think like the little ports in the back of a VCR. I need to know like where to put it in. X just shows, hey, put it here. So when I put the B in, well, I do what I did up above, right? Don't I do the exponent first? So B is squared. And then can I do anything else?
Nope.
No. I'm done. So the output, well, there's no combining I can do of like terms. I'm done. This is the output. And this one is going to be this whole equation. Now, my input wasn't a number, so my output wasn't necessarily a number either. Guys in the back, it's warming up, so let's go ahead and take the lids off. And let's double check how much we're paying attention. Guys, on letter C. Now, before I do letter C, can I just show you something, like a really silly example? This helped me at least understand this whole idea of input and output. I'm going to actually make it letter D, but it's kind of a funny, silly one. What if I was to do something else? What if I was to do f of, I don't know, what if I was to do f of cow?
It would be.
Every 3 cow squared.
Yeah. All you gotta do is say what goes inside the parentheses. Well, my input now is a cow. Now, in the olden days, I actually had like a whole little picture and there's a cute little cow. But the long story short is that you just say 3 times, thank you. That is the sound a cow makes. I'm very proud. Question. Question. Is it stressful when there are multiple things in my input, or does it just all get put in at the same time?
So you just keep like that.
Yeah.
So, what am I gonna do? What am I gonna do? This is actually a college professor told me about FFCAT. And I was like, oh, that's a really good way of doing it.
It's just weird.
It is weird, but it works because maybe you guys can understand a little better. A few of you did understand right away, and some of you are like, I don't know. What do I do with x minus 1?
3x minus
Plug it in.
Over squared. Plus 1, then you keep it like that.
You put in x plus 1.
Then that's your answer.
You put in the input. So like in letter A, I put in 2, letter B,
Can I
I
be
put
minus
in B,
1?
letter C, I put in x plus 1.
Why is it
Is there a minus?
Oh, grass is crossed. Angel, was that your question?
Yeah.
Okay, make sure to point it out. Thank you, I appreciate it. Let's go ahead and put this again.
Wait, so for that one, you would?
No. Would I just stop there?
No.
No. I should probably try to simplify it. But technically, is this, Dylan, is this right? Did I plug it in okay?
Yeah.
Yeah.
Oh.
But I don't have to stop there. I could go ahead and use my algebra training and do x minus 1 times x minus 1. I could actually simplify this and write it out.
That's too much.
Now I'm going to FOIL quickly just because this isn't the point of today. You guys see that I'm foiling and I'm combining and I'm distributing and I'm doing all sorts of stuff?
Yep.
Okay. So I have plus 3 plus 1.
Why not you keep it as your
Plus
answer?
4.
Yeah.
And that's.
Well, plus, it just took more work because it was a little bit more complicated. For instance, if you were actually supposed to put a cow in this equation, that'd be a lot more complicated too, right?
Yep.
Okay. So, the more complicated the input, maybe the more complicated to get the output. But that kind of makes sense even with technology, right?
Yeah.
The more complicated the process, the more complicated, like the more complicated the solution that you want, the more complicated the process will be to get there. But let's keep going as far as now at least you have the idea of, where you remember the words of input and output. Okay? Now, we gotta get into our notes for today. The words input and output are gonna come back. Okay? But it's gonna be a little different of what we're used to.
Okay.
Inverse. You guys have learned inverses from the beginning of algebra. As you guys write that, I'm gonna put something on the board.
Inverse.
Okay. I wasn't sure if they were getting monkeys, so I wasn't sure if they were still- It's a little too crazy, let's not go there. Okay. As you guys are writing down those words up there, inverses of relations is where we're going to start today. It's the beginning, the first half of the moment. And then we're just going to scratch the surface, just kind of do just a little bit of inverses of functions. Relations are like talking about points and tables. That's why you see an ordered pair up there. And if you guys look at the first example, before we even do anything, this first example, do you guys see all the ordered pairs?
Yes.
They're kind of hard when they're written like this. It's kind of hard to see. You're also going to see in the next example a table. That's a little bit nicer way of putting lots of points, right? Because you see the points. They're reminding us of input and output because input is like the X, output is like the Y. Now, just real quick, you guys have seen the word inverse before. It's just been a while. But actually, all of algebra, not all of algebra, but like all of solving algebraic expressions comes back to this idea of inverse. Meaning, if I wanted you to solve for x in this equation, my question is, what would your first step be?
-1 to
Minus
the
one.
side.
Now, you've been trained to do -1, but what technically are you doing? You're seeing the addition, and you're saying, how do I get rid of adding 1? And in your head, you're doing the inverse operation, and the inverse operation says, instead of adding, subtract. You've been trained. If you're adding a constant, I'll leave it until lunchtime. If you're if you're adding a constant, in order to undo it, we do the inverse, which means instead of adding, we subtract. Now, algebra also taught you, hopefully, that what you do to one side, you do to the other side. You get 4 equals 4x. Now pause. The inverse operation undid that addition. We were trying to undo the addition, and we have to move it to the other side. Now, question. How would you finish this problem?
Division.
Now, how do you know division? Because you've been taught. Division undoes multiplication. Division undoes multiplication. What you do to one side, do to the other. Thank you. But the point is not the answer. The point is the process. Division is the inverse operation of multiplication because division undoes the multiplication. So we're undoing what was done to x to get everything to the other side. And you guys, yes, the correct answer would be 1. But my question is, do you see the examples of what inverse means? You see addition, inverse says I'll undo that. You see multiplication, inverse says I'll undo that. Undo addition with subtraction, that's the inverse operation. Undo multiplication with division, that's the inverse operation. Inverse is like an undo button, kind of like on a program. It undoes, but in addition to undo, you have to subtract. Multiplication to undo, you have to divide. Now, we're trying to get into that idea. I just wanted to give you guys a really quick peek at what the bigger meaning is of the word inverse. But for these problems, before we get into the craziness of inverses of actual equations, inverses of relations, just say, hey, what was there in the beginning, A and B, where A was the input, because it's in the x spot, and B was the output. A goes in, B comes out. Inverse relations is totally flipped. B is the output, and A is the input. I can spell it right.
Would the signs flip too?
No.
Okay.
Inverse relations say take the outputs and flip them.
I'm so sorry.
So they put it on the desk. Thank you. Okay, so what were the inputs and the outputs of relations switch? What were the inputs and outputs of relations switch? So the order switches. The order switches, but we still technically say, okay, well, what was an input becomes an output, what was an output becomes an input. So I was trying to show you guys, the input and the output is technically of the beginning. A is the input, B is the output. For an inverse, everything switches. Now let's go ahead and just do that really quickly with example number 1. If these points are the original points of the relation, what would be the new points that would be in the inverse?
Instead of negative, there's a positive.
I have 2 books that are extras that should be up here. I just need to have one of them. Barry has one. Who has the other? Who has my other book?
I'm so confused.
There were 2 books up here yesterday, guys. They're both gone.
Are you sure they're
I think there's one right.
That's geometry.
The signs change.
Oh!
You don't have one of my books? No, but I usually have 2 books there.
Oh, yeah, you're right. I was thinking.
Kiddos, thank you for getting distracted in 5 seconds and then walk away. Let's come back to our notes. So, if I have these points, look up above.
I know.
relation is AB, inverse flips it to BA. So Johnny, what would 1 point be of the inverse relation?
-4, -3.
All we're doing is flipping the inverse.
Oh, that's so easy.
Yeah.
Easy.
What's the next point? Everybody go.
0, -2.
Next point.
4, -1.
And then I'm going to go ahead, and if it's okay with you guys, I'm just going to keep on going.
12,
1, 16 to 23.
20, 23.
Okay, so what's happening with all my inputs and outputs?
You're flipping it. Or inverse.
You just
I'm inverting them? Say that. That sounds snazzy. So my inverse relation, take all the points and reverse the order. So now, what do you think I'm going to do with this table?
You flip that.
flip the table.
Exactly.
Input goes to
So make a new table.
0, 1, 4.
It's not bad.
Wait, do we have to graph afterwards?
Okay, so I'm going to make a new table, and here's what I need you guys to see. When I make a new table, I need the outputs to go into the inputs, and the inputs to go into the outputs.
Yep.
So, even though technically what was the input is going to go in.
The
Okay,
output.
get it quickly. No, it's just refocus. What was the input becomes the new output. And what was the output becomes the new
Input.
input.
That's light for you.
So we need to go ahead and do it. We have 1, we have 2, we have 3, we have 4, we have 5. So guys, what would the points be for?
4. And -2. -2. 1. -1. 0, 0. 1, 1. 4, 2.
Does that make sense? So in order to show that, let's come back up to the front really quickly. Up to the top really quickly. What I need to show you guys is the output becomes the input, so those match. And then the input becomes the output, those match. But it's basically just we're switching the points. Now this idea of input and output is going to be really important though when we get to the next big topic. Good job on those ones, but we have one more idea. What happens when we start going to equations? It's not relations anymore, we're in functions. F of x. According to the directions, solve for the input, plug in the output. Now here's the weird thing. Solve for the input. Question, who's the input in, say, number 3? No. No.
-6.
Who's the input? X, just x, remember? Remember? We talked about that. Look in here. X is the input, right?
Yeah.
Okay. Where is the x in the equation?
Right there.
Right there. So according to function notation, x is the input. So when it says solve for the input, it means don't get y alone like it is right now. Instead, get x alone. So to get x alone, I'm going to go ahead and add 6 to both sides.
So y plus 6. So x equals 6.
So we could say f of x plus 6. If my stylus here. But we don't usually, when something's alone, we don't usually write them at the end. Usually we write them at the beginning. So to make it a little bit nicer, I'm going to do x equals instead. And when we do x equals instead, f of x was just the snazzy name for what?
Y.
So we could write it x equals f of x plus 6, or if you like it a little bit better, we could go ahead and write x equals y plus 6. Now, that's the first step, solve for x. We've done that. We can go ahead and box. But they ask us one more thing. What else did they ask us? Solve for x, we got it. X is alone.
Output.
Find the input when the output is 4. Find the input when the output is 4. Okay, so if the output is 4, question, in the original problem, who was the output? No. No. Y was the output, right? X goes in, Y comes out. So I wasn't saying no to every single person because a lot of you guys answer differently, but if we know the output is 4, we're going to go ahead and say who is 4?
The output, which is
Y is 4.
Why?
So that means in order to solve, we're going to go ahead and plug in chug and say x equals So what's changing is we're plugging in the y instead of the x. My guys that are dancing, you can stay in here and dance a little bit after the bell rings.
Now, if the output is just like, let's say, 4 negative,
Well, I don't know exactly, if the 6 is negative, then I guess we would treat it like a negative number, but it's not, so we're not treating it like a negative. Okay? So I would say the final answer, x equals 10. Now, kiddos, on number 4 then, how would we solve for the input? Very.
Put x in alone, so x, so it's y minus 3 times 2, like 12 times 2.
Good. So we would subtract 3 first. We would have f of x minus 3 equals 1/2 x. How do we get x alone now?
Multiply 2.
Multiply by 2. What we do on one side, we have to do to the
Other way
Now, why is it super important I put parentheses in?
Because you gotta multiply.
I have to distribute it to all the terms.
Oh, wait, no,
So then when I distribute, I'll say 2 f of x minus 6. Careful, I have to distribute the 2. Equals x. Now how do I write this prettier?
Swap them.
Swap them, and then what's f of x is now name for? So that is solving for x.
Then you plug in 4.
And then if the output is 4, all I gotta do is just plug in. So they've given you different information than they've given you before, but it's not way different than other things that you guys have been doing, just some of the names have changed. Because
I
of
see
the
what
y is 4, so I get to plug in 4, so x equals
2.
8 minus 6, which is 2.
2.
So today is very foundational. It's like teaching you terms. Today is teaching you terms. Today was also teaching you or reminding you about inputs and outputs. Today was also teaching you about inputs and outputs. Now guys, the sad thing is because we had so much vocabulary to go over today, and because you guys did just really slow down the lesson because it could have gone so much faster. We're not going to have lots of time for homework questions. I don't think you guys really need to see that one. You do have the new homework written down. I do realize that a lot of people had homework questions, and if you allowed me, I could have helped. I'll help on maybe one right now, because I think that's all we have time for. So I'm going to go ahead and go to the very end of homework. That's usually the hardest part.
Yeah.
Smartboard's not working. That's usually the hardest part. But let me go ahead and see. Let me see.
Just do it. Can I use your sleeve?
I would agree that I think 51 is a little bit, yeah, I would agree that 51 is a little bit harder. So let me go ahead and write down 51.
I'll take down notes. Yes.
All right, we're staying 2 minutes after. Now it's 4. Now it's 6. Now it's 8. It's ridiculous how much time it takes. That 8 will get cut down if you'll just let me help with one homework problem out of 1, 2, 3, 4, 5, 6, 7, 8 that your class wanted to see today. I don't know how else to get through to you guys unless I show you that you are hurting yourselves and you're hurting each other and you're understanding of algebra. And I know a lot of you guys don't want summer school, but you should have asked like it when you were here. Number 51. For those of you guys that have your homework, it was 1 minus 3a, is that right? Equals 2a. Remember, you are turning in your homework before you leave. And I'm going to go through this one because it was hard. If you guys help me, I'll let you leave early because this should not take 8 minutes. Why am I squaring both sides?
Because you need to get rid of the square root.
Get rid of the square root. What happens on the left? What can I cancel out?
Square root and then
Good. So what is left on the left?
1 minus 3.
Now, on the right, it's a little bit harder because you need to think about 2a times 2a. So there is a 4, but there's also
A squared.
an a squared. Now, this is what gets harder to solve because I have a quadratic. But in order to solve a quadratic, I'm doing inverse operations. You guys see how I'm trying to get rid of the left side?
Oh, yeah.
But what I do to the left side, I have to do to the right side. So I've gotten rid of everybody here.
Yeah, okay, what's it called?
Now is where it gets a little tricky. A lot of you guys are like, ew, I don't like factoring, especially when there's a number in front. So what is another way to solve this?
Quadratic
Can't
formula.
define. But I could use the quadratic formula. I can use x equals negative b plus or minus square root b squared minus 4ac.
All over to.
Exactly. So then a is equal to 4, b is equal to 3, c is equal to negative 1. So when I go to solve, I would say, oh wait a minute, but I don't have an x this time. Who's my variable this time?
A.
It's a little weird, but we can still write it. A is equal to negative b plus or minus square root b squared. Can I make it 9? Is that okay?
Yeah.
Minus 4ac all over 2a. Now the problem is we do have to go ahead and finish. So I have negative 3 plus or minus. Can anybody help me out? What's negative 4 times 4 times negative 1?
16.
Positive 16.
Oh, it is.
Also known as 25.
And 2 times 4 is? Johnny's already been like, hey, 9 plus 16 is 25, so we can jump there.
Which is 5.
How do we finish?
That's negative 5.
Jay's saying yes, that is going to be the same thing as not. The square root goes away when I take the square root, right? So I have a equals, why am I going to go ahead and split this up into 2?
Because it's plus or minus.
Plus or minus, so plus 5 over 8, and negative 3 minus 5 over 8. And I end up with 2 over 8 is 1/4, that's one answer for A.
Yep.
Or
Or.
A equals negative 8 over 8, which is,
Negative 1.
and at this point, I think Kaylee, this is yours. Remember, you do have to kind of check them and make sure it's not an extra units at the beginning. But that's the solving part. That's the solving part. Kiddos, you have to turn in homework 61 and 62.
Can I get my book?
61 and 62? Yeah. You can hand to me on your way out of the room. If you had extra questions we weren't able to go over and you're afraid you'll lose points, come in during lunch or after school and we can go over them.
I turned in 61 yesterday.
So if you had questions and you're afraid you'll lose points, come on in and I can explain them to you. I'm sorry that we weren't able to get them.
How should I rate the lunch for 63?
I did a box, can I just leave it in there?
This is fine. That's it?
Yeah, simplify all
I did a box, can I just leave it in there?
Put it,
I did it in the box.
That's fine.
put it back down.
I'll take it or put it in the box.
That's the other one.
Put it on the very top of all the trays, Barry, and I'll put it in after I pull it out.
Right here?
Ouch.
On top of that.
That hurt.
And I'll put it in once I pull it out. Thanks, Barry.
I'll come after school today.
Okay. Because you've been able to stay on top of current homework. Now you're working on old. Okay.